This isn't exactly a topic on its own, but you are going to be doing this lab called Seeing Inequalities Part 2. And before you try to do it on your own, I thought I would just give you a few examples of how to do the different problems. So at the top it says use your foldable to write which inequality you would use for the following phrase. So if you look at your foldable, at least, less than, no more than, greater than, those are all on your foldable. So pull that out and look and see which inequality you should use when you see those words. And that'll help you out a lot. So let's look at the instructions. The instructions say, write the inequalities to represent the following situations and graph on a number line. So the first situation says Cameron's parents have limited back-to-school shopping to no more than $150. So the main phrase that we need to look at is no more than. So if we were to go up here and look at our chart, you should be able to pick out the inequality that we would use. And it says, what is Cameron's spending limit? Well, no more means that we should really have less than $150. So we would say C, which is Cameron's spending money, needs to be less than or equal to 150. And that's it. We've written an inequality that represents the situation, and now we're supposed to graph it on a number line. So 150, I'm going to do a solid dot because of this line right here. So solid dot, doesn't really matter where you put it, label it 150. And then if we use our test number 100, it's over here. So 100 is less than 150, yes. So we would shade this direction. Good. Number 2, Chance is 5 feet tall. When he stands on a chair, he can reach at most 16 feet. So again, the key word would be at most. And again, you could look up here to find out what inequality you were supposed to use. But we kind of want to think about it. If C represents the height of the chair, how could we represent this situation? So first, he starts at 5 feet tall. Then from there, we add the height of the chair. So that would be plus C. And when we put his height plus the height of the chair, the highest or the at most that he can reach is 16 feet. So we would say that has to be less than or equal to 16 feet. So then to solve for C, we would have to subtract 5 from both sides. And we would get that C, the height of the chair, has to be less than or equal to 11. So then we would put that on a number line. Again, we can put it wherever. It would be solid. So here's 11. This time our test number of 100 is up here. So is 100 less than 11? We would say no. So we would shade away from the 100. Good. So now let's look at number 3. It says Kayla is making candy. Her brother ate 5 ounces of the candy, and now there is less than a pound left. If C represents the original weight of the candy in ounces, they want us to write an inequality that would represent the situation. So if we kind of think it through, if C is the original amount of candy in ounces, we could go ahead and put C. Then from there, we need to subtract what her brother ate. So if we do minus 5, and it says, and now there is less than, so there's those words, less than a pound. but a pound isn't in ounces, which is why they gave us this information that 1 pound is 16 ounces. So if there's less than a pound, we would say there's less than 16 ounces left. So now we would do plus 5, plus 5. I really probably should have written it over here. So I get C is less than 21. So I'm going to go ahead and draw the number line just as a reminder to you, but you need to go back in and do the graph. All right, number 4. Research indicates that 95% of people have a palm width that is at least 3.12 inches long, but no more than 3.8 inches long. This information is used when companies design control panels, keyboards, and gloves. So the first thing first, we need to define our variable. So P is going to stand for our palm width, because that's what this whole problem is about. And then if we're trying to describe our palm width, it says our palm width is at least 3.12 inches, but no more than 3.8 inches. So we actually have two separate inequalities here. At least, if we would go up and look, okay, at least means that we have to be more than 3.12. So our palm width has to be greater or equal to the 3.12. But then we also have this piece. So we have and our palm width then is less than or equal to, because it says no more than. So, well, if it can't be more, then it has to be less than 3.86 inches long. So since it's an and, we could actually write it as a combined inequality. Remember, if it's and, we can put the variable in the middle, and then we would always have less than or equal to signs. And then we would put the lowest number on the left, so 3.12, and the highest number on the right, 3.86. So now it has both pieces. P is greater than 3.12, but P is less than 3.86. And then I'm going to leave that for you guys to graph on your own. All right, so now let's look at the bottom. The instructions do change just a little bit. This says write an inequality for each situation below, and then it says solve each inequality and graph the solution. So now we know there's going to be a little bit more to it than just what we had before. When you're trying to solve these, a lot of the times you are going to use your 2-7 notes. So if you still have those, you might want to get them out. So we're back to a number. You can use N, you can use A. I always choose to use X. So a number that we don't know. Decreased by, so decreased is subtract. -4. And then it says is. Usually we would put an equal sign, but it says is at least. So then we would have to go up to the top and figure out when it says at least which one we're going to use. So if it has to be at least, that would be greater than or equal to 9. So this would be x minus -4 greater than or equal to 9. Well, negative would make a positive, so this would be x plus 4 greater than or equal to 9. And now we'd be ready to solve. So if I do -4 minus 4, I would get that x is greater than or equal to 5. And that would be our solution. And now we need to graph that on a number line. And again, at this point, I'm hoping I shouldn't be helping you graph. But there are some different types of problems that you might run into, so let's look at number 6. Number 6 says, what is the width of a rectangle whose length is 4 feet and has a perimeter that is at most 20 feet. So the biggest thing that we need to know here is, what is perimeter? Well, remember, perimeter is the distance around. So if this was my rectangle, then this is the width and the length and the width and the length. So perimeter is the distance around, and I was going to write it. I would actually have perimeter equals W plus L. I'm going to make it an actual L. Plus W plus L. Well, now if I put my like terms together, W plus W is 2W, and L plus L would be 2L, right? So my formula for perimeter would be 2W plus 2L. So if I kind of think about that as my equation, now it says, what is the width if the length is 4 feet and we know the perimeter? So I don't know the width, so I would still have 2W, but we do know that the length is 4. So this would be plus 2 times 4. And then it says is, there's that is again, but it's followed by at most. Well, at most means that this is the highest number that we could have. So we would say that this is less than or equal to 20. So from there, you should be able to go through, multiply here, and then solve for W. And then don't forget, once you get it, you need to graph it. And I'm going to draw it over here, since you may not have room over there. Good. All right, so then let's look at 7. 7 says triangle FGH is an obtuse triangle. The greatest angle in the triangle, greatest meaning biggest, has a measure of 6D. What are the possible values of D? So the first thing that we need to know is, what is obtuse? Well, there's 3 main types of angles. You have acute, which means a cute little angle. And for acute, the angle, or the value of the angle, would have to be less than 90 degrees. If they told you it was a right angle, then it's going to be equal to 90 degrees. But obtuse is special. Obtuse is between 90 and 180. Now, it can't be equal to, because if it's equal to 90, it's a right, and if it's equal to 180, it's actually called a straight angle. So this means that it's equal to 180. So we can't put equal to's on there, but so that's the information. So if I have an obtuse triangle, which would look something like this, anything that's more than 90 degrees, and I labeled it FGH, and again, it doesn't matter where you put them, it says the greatest angle, or the biggest one in the triangle, has a measure of 6D. Well, the biggest one in here is G. So there's our 6D. And it says that it wants to know what are the possible values of the angle. Well, we just said that 90 would have to be less than the angle, which would have to be less than 180. So if I replace the word obtuse with the 6D, I should be able to set up an equation that I can solve. So if I take 90, and that should be less than our angle, which is 6D, which should be less than or equal to 180. Now, all I would have to do is divide both sides, because remember, there's 2 separate lines here. So divide by 6, divide by 6, divide by 6, and I should get my answer. So you need to fill in this, and then don't forget to graph. And then once you've done that, you're ready to come up and get the second half of your lab. Okay, you guys kind of have to see this. We have guests helping us with our... Here is one little doggy. And then coming across. Here's the other doggy. And they're all sleeping while I do my video. Anyway. Oh, look, and there's my kid waking up. Time to go. Bye.